So we got the segment AB. M is the midpoint that bisects the segment. We're going to find some stuff about this, but before we do that, I want to bring something to your attention that I'm just not sure everybody is 100% comfortable or aware of this. These marks are important, these little dashes right there. What do those mean?
Halfway to halfway.
Okay, so it has something to do with halfway stuff, but in this case halfway, but we'll be seeing these things all year long, and just in general. Can somebody tell me what those two red dashes are all about? Somebody raise your hand and help me out with this, or take a stab at it. It has to do with measurements, sort of. What about it? In this case, we put those there because M is the midpoint. So these red dashes are telling us something about these little segments that have been cut from the big segment, segment AM and segment MB. What's true of those segments?
Yes, sir. The same length.
They're the same length. Yeah, they're the same length. And what these are called congruence marks. And what these are telling us is specifically this. They're telling us that segment AM is congruent to segment MB. And so that weird looking mark there, it's an equal sign with a tilde on top of it, is called a congruence. Sorry, congruence symbol. And that's, well, yeah, we'll get to that. In Moodle, it's going to be a little different. There will be a way to do it, but I don't want to tell you right now. You won't need it yet. You won't need it for a little while. So congruence, now, here's what I got to remind you about. Congruence is not the same thing as equal. When I say that those two segments are congruent, this doesn't seem like much of a difference, but it is a difference, an important difference in geometry. Geometric things are congruent. Numbers are equal, right? But things are congruent. So segment AM is something, it's a geometric thing. I could draw it on the board, or I could point to it, okay? MB, same thing. This means that if I were to pick up segment AM, I could set it down on segment MB, and they would overlap perfectly. They're the same size and shape, which is what congruence essentially means. Now, because segment AM is congruent to segment MB, that also tells us that distance AM, aka the length of segment AM, same thing, the distance AM is equal to the distance MB. Now, those are just numbers, so those are equal, but the segments are geometric things, so they must be congruent. Okay? That may not seem like a big difference right now, but you'll get to appreciate as we go on that that is a pretty big thing. Okay, so now what can we do with this? So let's get some additional information. Let's say we also know here that the length of segment AM is equal to 12x plus 3, and the distance from M to B is equal to 10x plus 5. So how could I solve for x? Not exactly in this case. Minus, you have an idea?
Would the equation have like equals, like the whole line equals to a certain point?
Close. What was the suggestion over here?
So AM is 12x plus 3, so you just substitute it.
Okay, good. We know that the distance AM is 12x plus 3, and the distance MB is 10x plus 5, so I can set those distances equal to each other.
I left my bag.
Oh, yeah.
Good job.
Bring my keys back.
There you go. Right there.
Good.
You won't even let me wear this hat.
Okay, so that's right. Okay, so we could set 12x plus 3 equal to 10x plus 5, and that's easy to solve. And look what we've done there. We've taken a geometry picture, a geometry situation, and the only thing that allowed us to do this is those little congruence marks that told us that this was equal to that, right? That those segments were congruent, so their measures were equal. Set those distances equal to each other. You know, I just subtract 10x from both sides, subtract 3 from both sides. 2x equals 2. So what do? Divide by 2, and I get x equals 1. Okay. Now that's part of the deal. That's not the only thing I asked about. I also wanted to know what is the length of segment AB, or the distance from A to B. Same thing. What can I do? Plug that x value back into these two distances and then add them up, right? If I plug 1 in for x, I get 12 times 1 plus 3, which is what?
15.
And then that, if that's 15, that's also 15.
30.
So 30 is my total distance. Okay? Good. All right, so. Okay?
How do you not say about 30, 30, 0, 1?
What's that? Okay, so a segment bisector, that's the thing that is doing the bisecting. So it could be lots of things. Could be a segment, could be a ray, could be a line, could even be a plane. Whatever is cutting that segment in half is the segment bisector. So in this case, segment AB is being bisected. There's the midpoint M. Is being bisected by line, you can't really see that K there, but there's a K there. That's line K is the line that's cutting through the segment. Find it? Okay, so that's the line that cuts through the segment at its midpoint, so it's the segment bisector. Now, what about this one? Here's another issue we got to deal with. This is going to make you scratch your head a little bit. We want to find the midpoint of segment SP. We can make that a segment.
You make it a line.
Okay, so find the midpoint of segment SP. Now, they're giving me the coordinates here of point S and point P. Those are the endpoints of the segment, and asking me to find the midpoint. Okay. Suggestion, yes. Well, I could probably make the distance formula work, but there may be an easier way to do this. Okay, I am going to draw a picture, but we're going to come up with a way that doesn't make it necessary. We're not going to have to graph things to get this answer. But for now, maybe it's easier to see it if I graph it. So we'll do that. So point S is back 3 and down 5, so we'll put it about right there. And point P is over 5 and up 11, so we'll put it about right there, let's say. Okay. And we're trying to find the midpoint. Now, graphically, we can sort of get a pretty good idea where that's going to be, but it's not going to be necessarily exact. We want to come up with a way to get an exact answer. The midpoint looks like it's about right there, right? Something like that. I want to know the exact coordinates of that midpoint, though.
So is there some equation probably?
Yeah, there is. We're going to come up with a very simple equation for this. Actually, you're going to come up with it. Think you got it?
No, but like, wouldn't it be just a lot easier just to put it like on the graph?
Okay, but what if?
I got a question.
Now, what if? That's a good point. The question is, why couldn't we just always slap it on some graph paper? What if the endpoints were at like negative 3.17 and positive? You see what I'm saying?
Yeah.
We're gonna have troubles.
Why wouldn't you just like do the distance formula?
Because we're gonna come up with a much easier way. Much
It's
easier.
probably something like this one.
Okay, now here's what I want you to think about. Everybody's got to play just a little game here. You got to use your imagination.
I thought.
Hold that thought for just a second. Hold your thought for just a second first. Now I'll get to it. Think about here's the game we're going to play. Imagine that there is an ant that is starting at point S and it's going to walk up to point P. Now we're going to watch this process, but we're going to choose our vantage point carefully. Okay? So first, let's choose the vantage point where we're way up high in the air, looking straight down on this thing. So we're like in a blimp or something, looking straight down. Now, what is this segment going to look like if we're looking down on it from above?
You wouldn't be able to see it. You just told us in real life you would be able to see it.
You'll be able to see it. But is it going to look this long to us if we're looking down from above? It's going to look shorter, right? It's going to look shorter because we can only see the horizontal part of this thing. If we're up above it, we're not going to necessarily see the vertical part, right? We'll just see how wide it is, not how tall it is, right? And so when we watch, let's say that we're watching this over an XY plane, so we can see what the coordinates are, we would see that the ant would start off with an X coordinate of -3, and he's going to walk along that line and end up with an X coordinate of +5. Seen from above, he just moves from -3, an X value of -3, to an X value of +5. So what would we pinpoint as being the middle of his journey, the midpoint, in other words? What X value? How'd you get that? You're right, how'd you get it? See what's in the middle? The middle value, the middle X value is going to be the X coordinate of that midpoint then, isn't it? Because when the ant is on the midpoint, when he steps on that red dot at the midpoint, we see him as stepping on an X value of +1. right? And that's accurate. That is his x value. Now, is there a way in math for us to very quickly and easily find a middle value of two numbers?
Yeah.
What is that?
Add
Add them and divide by 2. What do we call that when we add two numbers and divide by 2? Okay, we call it a mean or an average, right? And they are just saying, they're two words that mean the same thing. A mean or an average in math means the middle value. That's exactly what it means. And so that's an easy, efficient, quick way for us to find the x coordinate of the middle is just average, of the midpoint is average the two x values. So negative 3 plus 5 is what?
2,
Divided by 2
1.
is 1. How about that? Now, if we want to find the middle y value, we'll do the same thing, but this time we're going to look from over here, from the side. So all we see is the vertical motion of the ant. Then we're going to see the ant starting off at a y value of negative 3 and ending up at a y value of positive 11, right? And what are we going to pinpoint the middle value to be there?
You mean 5.
What did I do? Oh, supposed to be negative 5. Whoops, I'm sorry. Yeah, you're right.
Supposed to be negative
You're
5
right.
there. You wrote 3.
Gotcha.
Yeah, there you go.
Okay, so we needed, yeah, you're right, we needed a negative 5, whoops. Negative 5 and positive 11, right? So what's the middle value of negative 5 and positive 11? Divided by 2, right?
3.
So it'd be 3. Negative 5 plus 11 is what?
6.
6. Divided by 2?
3.
3, right? So we got it. So the midpoint then, we know what the coordinates of the midpoint would be just by focusing on the average x value and the average y value. And so here's our formula. It's a very simple formula. So if we're calling the endpoints in our formula, we're going to call one of the endpoints x1, y1. Those are the coordinates of endpoint number 1. The coordinates of endpoint number 2 are going to be x2, y2, right? And then here's our formula. The midpoint is just the average of the x values for the x coordinate and the average of the y values for the y coordinate. All right. No big deal.
You know, I like the way that you told us just like 1 page ago.
You like the ant way better?
Yeah, don't even show this to us.
Okay.
You,
All
you
right.
make it look like way harder than it is. Like,
Yeah.
we understand the whole adding and the dividing, but when you put it into that, it looks kind of dumb.
Okay, so now, if we look at that last example then, here's just a real quick, this is what it looks like, right? The previous example we did. If I average the two x coordinates and average the two y coordinates, then that's how we got our x equals 1, y equals 3. Okay, no big deal. But we could make it a little bit harder. Let's make it just a little bit harder. That wasn't challenging.
Hard.
I don't
Hard.
Yeah.
Hey, we don't like it hard.
Okay, so let's try this one. AJ, why don't you grab your stuff?
Quiet when you let loud.
Well, I don't appreciate that. Grab your stuff, man. The midpoint of AB is this point right here. So everybody take a look at this. Park it in the hall. Okay, the midpoint of segment AB, everybody with me?
Thank you so much.
The midpoint of segment AB is point M. Now, look, this is a little different. Everybody pay attention to this real closely. This is a little harder question, but it's not that bad. So they're telling us the midpoint has coordinates 2, 4. Now, one endpoint is at A, and it has coordinates -1 and 7. Now, this time, they're not asking us for the midpoint. They gave us the midpoint. What they're asking us for are the coordinates of the other endpoint. Okay? So does that make sense? So the ant's going to start off at this point, -1, 7. He's going to walk along this segment. Halfway there, he's going to be at the point 2, 4, but he's got to keep going to get to point B. Now, how could we do this? Now, I guarantee if I gave you some time, you could puzzle this out and come up with an answer, but let's see if we can come up with a strategic way to do this using the midpoint. Okay, you have a suggestion for that?
Sorry.
Yeah, and I anticipate probably what people are going to tell me is, I'm just going to find that distance and double it, which is true. But is there a way we can use the formula? Yes, ma'am. William. Well, we could. we could graph it, but once again, what if these points weren't nice, convenient ones? What if it was negative 1.379? Then it gets tougher, right? Yes? Kind of. But let's take a look. If I start off with the midpoint formula, and here it is, right? Now, think what this is telling me. The average of the x-coordinates of the endpoints equals the x-coordinate of the midpoint, right? The average y-coordinate of the endpoints gives us the y-coordinate of the midpoint, okay? So then in this case, now the coordinates of the midpoint are 2 and 4, right? So the average x value must be 2. Agreed? Okay. What is x1? -1, isn't it? It's -1 because we know one of the x coordinates. Now what's x2?
3.
We don't know for sure what that is yet. I mean, we're going to find out, but that's what we're looking for, isn't it? We're looking for the x and y coordinates of the other endpoint b. So this is one of the things that we're trying to find. And there's the other thing that we're trying to find. So those are going to be my unknowns in the little equations we get, right? So let's plug in the stuff that we've got then. So I end up with x1 plus x2 over 2 equals 2 because that's the x coordinate of the midpoint. That's the average x value. If I plug in -1 for x sub 1, I get this little equation, right? Everybody see that? Where I get that? The average of -1 and x sub 2, which we're trying to find, has to be 2. Now the algebra to solve that is very simple. There's 2 steps. What are they going to be in order? What do I do first if I want to solve for x2? Not divide. Multiply by 2 to get rid of that 2 on the bottom, right? So multiply both sides by 2, which gets rid of the 2 on the bottom and gives us 4 on the right side. And then last step, add 1. So I got it. So the other x coordinate is 5, and that makes sense, doesn't it? If -1 is the x coordinate of one endpoint, 2 is in the middle, then 5 would make sense as the other x coordinate because 2 is in between -1 and 5, right? Okay, let's look at the other side. Now this time I know that the average of the 2 y coordinates must be 4 because that's the y coordinate of the midpoint. I'm going to plug in 7 for y1 because that's the y coordinate that I know, right? And that gives us a little equation to deal with. Okay, same steps as before. Multiply by 2, right? To get rid of the 2 on the bottom. And then in this case, what do I do? Subtract 7. Good. And I got it. Y sub 2 equals 1. So I got them both. I got the x coordinate and the y coordinate of the other endpoint. And so there it is. There are the coordinates of B. Okay, make sense? Okay. All right, last issue. Not a big deal. We can also bisect angles. To bisect an angle also means just to cut it in half. So a ray that divides an angle into 2 congruent adjacent angles is an angle bisector. So in this case, we'd say that ray BD bisects angle ABC. Okay? Now, what does it mean, real quick, I'm sure you can tell me this, what do these little marks mean here? Yeah, good, that those little angles are congruent. Perfect. Okay, those angles are congruent. Now, what does it mean, real quick here, I want you to tell me something. Tell me if I've got, let's say, I've got 4 segments. Okay, what does that mean? Let's call this one, oops. Let's call this one AB. this one is C, D, this one is E, F, and this one is G, H. What do those marks mean? Okay, what are congruent? All four of them? No, okay, what's it mean?
Well, that means A, B, and C, D are
Oh, okay, good, so it tells me that AB is congruent to CD. Segment AB is congruent to segment CD, and
E, F, G, H.
segment EF is congruent to segment GH. Good. Okay, what about this? What if I've got some angles like so? Let's call this angle 1, that angle 2, that angle 3, and that angle 4. What does this mean?
One and two are the same.
Okay, 1 is congruent to 2, angle 1 is congruent to 2, and angle 3 is congruent to angle 4, right? Are angles 2 and 3 congruent? No. Good. You got it. Good. Okay, so then we'd say that ray BD is an angle bisector. What about this situation? What if I know that ray FH bisects angle EFG? And I know that the measure of the big angle, EFG, is 120 degrees. What would the measure of the little angle, EFH, be? 60. Has to be half of it, right? Okay, good. Last example. What about this one?
Oh.
Okay, so I've got okay, so this time, let's say I want you to find for me the measure of angle A, B, D. How could I do that?
Got it.
What do you think? Yes, sir.
Well, would you combine like terms with the x's and then just
Okay, what's the equation? First, tell me the equation that we're going to set up in this.
x plus 40 equals 3x 20?
Good, because these two angles are congruent, their measures are equal, right? They're the same size. So we can set up a simple equation here. X plus 40 equals 3x minus 20. Solve for x. So subtract x from both sides. Add 20 to both sides. Divide by 2, so I get x equals 30. Is that my answer?
No.
No, it's not. What's my answer? Yeah. What's it going to be? If I'm plugging 30 in for x, 70. Yeah. I'm going to get 30 plus 40 is 70, right?
Yeah.
All right. Does that make sense?
I'm only-
Perfect. We got it. Okay, let's head down.